Okay, good afternoon, everyone. Welcome everyone to COM 2160. Hopefully you guys are doing okay. So far, so good. You guys can hear me and see the slide as well. Can anyone can confirm on the chat box? Okay. So we are kind of at the very end of our course. Like we only have four classes left after this class. Okay. So my plan is to cover the garbage collection today, and then I will give little bit idea of how we can use class in our C programming language, like kind of a flavor, and then we'll see some code on Monday's class. So your assignment number 3 is due on tomorrow. So try to submit within the deadline for sure, otherwise there will be late penalty for sure. For this time I cannot increase the deadline because assignment 4 will be up soon. Okay, on Monday I will just discuss a bit about assignment number 4 also, and hopefully on Sunday I will upload it. Okay, so far so good. Your lab went well, I think so. uh, Tuesday and Thursday lab. Okay, so your TA will grade, I think TA will start grading from today, so hopefully we'll get marks soon. So let's start. So last class we already know like what we learn about the garbage collection. Like at first we went for like why we are using this garbage collection. Then we talked about a simple garbage collecting memory manager called buffer, right? Or the object manager, you can say. So in this class, at first we'll go for a little bit like recap things, and then we'll go for what is called memory fragmentation, then explain what is being created by using double buffering. Okay, how we can implement a defragmentation algorithm with that double buffering in C. Then I will describe a bit about the inheritance and the polymorphism, and then how we can implement those things in C, kind of using the new term called union. So you already know structure. Now we'll introduce another one called union here. So any questions so far? Okay, so this is the buffer we talked about the last class, right? So it's kind of a linked list, right? So each of the node has some properties or the members, right? So those are like start or offset, length or size, so count or reference count. Okay, so in the figure actually we are using the count rather than the reference count. Also ID or reference, so we are using the reference actually. Okay, so this is the actual like the initial things, and now we went for uh, like the interface things and a main program. We didn't go for the implementation details. Actually, that is left for your assignment number 4. Okay, so the interface is already given in UMLearn. Also, the kind of a main function is already given. So if you look at the header file or the interface, or and also the main file, we are kind of describe this portion, like what will be happening like whenever you are creating some object, adding some reference, okay, then dropping some reference, right? So whenever we drop this reference, okay, so reference ID is 3 and reference count, you know that whenever you drop that it will be go to 0, right? So what will happen then, uh, after that you are adding another reference of id number 2. Okay, so id 2 means this number 2 is this is kind of working as id. So previously it was 1. Whenever you add the reference, like kind of you are using that one again, so your reference count goes up. like how many times you are using this particular memory. Okay, so that means the count. Clear? So then what we're doing, we're inserting another object, right? So whenever we are using like inserting another object, so you know that previously the id 3 was deleted, so this will be id 4, right? So the count will be 1, right? So then what we're doing here, we are using a for loop. If you go to the main o.c, okay, and then there comes like the things that you can see in this buffer, that whatever we delete, right? So we're just dropping the reference. Actually it's using the memory, right? So dropping the reference means what? We are just like kind of updating our link, nothing else. Previously it was like that, right? Dropping means we just update our link, like we are saying that now it's point to null, okay, and then adding another one, so we're kind of just updating the link, but the memory is still there, right? And that is not used. So that is the main purpose of the garbage collection, how we can just free up the memory that is not using, right? And we need the more memory, right? What we can do then, that's the main purpose of garbage collection, right? So how we can clean these things up, that's our main purpose, right? So whenever we have like maybe we are going to do inserting another object, right? If we have enough to allocate the memory, we can do it, right? But what if we don't have enough memory? What if like we are running out of memory? We cannot allow any memory, or we cannot uh, perform the operation like the insert object, right? Clear? So then comes, we have to free up the unused memory, right? Okay, so what we're going to do, we have to search like if there is like any unused portion. We know that for that id things, the count for sure it will be 0, because we are updating the count whenever we are dropping the reference, right? So then we need to remove that, right? So what we can do, okay, so for now suppose the buffer is look like this, so there are some unused portion, right? So we are just dropping that, but we didn't free it up, like the memory is used, right? But we cannot insert anything because it's being occupied, right? So now I want you to think about it, okay? So do we need to do anything to the memory that the node pointed at? If so, what? Okay, what is wrong with the entire buffer after removing the memory from it? What might happen? What we need to do? Just think, and if you have any suggestion, you can post in the chat box, or you can comment. Anyone have any suggestion like what we are going to do now? So this is actually called the fragmentation. So you know that our memory is kind of fragmented, right? Fragmented means divided. So we have like initially this one, then we have some unused portion and used portion and unused portion, used portion, right? So it's kind of fragmented. We call it memory fragmentation. So let's see the reply from you. So we can shift the start pointers to fill the empty space. Shift the start pointers, but start pointer is like maybe here, right? Then you have to do it like manually, right? Or like you have to go each of the portion manually, right? So that can be possible. So Matthew asked, should we maybe get rid of spaces between the used space? Get rid of the space in between the used space. Yes, for sure. Yeah. So that's our target, right? So we don't need this, right? We don't need this, right? Clear? Compact it for sure, yes. So that's the main function you're going to design in S number 4. The name is compact, okay? So after removing, so Adrian says after removing it, probably need to link the memory back. Yes. Uh, Cochin said to leave empty space on the right for the insertion. Yes, but there are some unused portions, so you need to actually care about that one, right? So let's see what we can do now. So this is, I already said, this is called fragmentation, right? So when we remove nodes from the list, our memory becomes fragmented, right? Like there are some resource allocated, but we are not using it, right? Okay. So now I want to show you one nice video from Windows 95. Okay, how it was back then, like defragmentation things work. Okay, so actually in those days, actually I even can remember like I did that also. So you have to do it like manually. So just like this. So this is actually Windows 95. So the memory, so whenever you do like file things, copy, paste, cut, paste, you know that memory will be fragmented for sure, right? So we need to defragmenting, right? So now this is the way. So same things like we said in the example, there are some empty spaces, right? The resource were are allocated, but we are not using those anymore. So just like that, okay. So now see like how Windows 95 back in those days like defragmented those portions. So it will go one by one and just reshuffle things. So it says the defragmenting file system, just like that. Okay. So hopefully, so it's very like you know that the current operating system, we don't need to do anything like that. It is done automatically. Like, but previously you have to do it by yourself. Like, uh, you have to run this like maybe after 1 week every time. Okay. So this is not a new problem, right? So this defragmentation things, it's there in operating system, right? So what's our target now? We have this buffer, right? And there are some resource allocated, but we are not using these white spaces, right? So our target is to convert this buffer to this one, right? To the lower part, so that they are the used one should be consecutive, right? And then we can have free spaces over here. That's our main target, right? So how we can do it? Ideas to defragment. Now try to think of a way you might approach defragmenting the buffer. So what can be the solution? Like previously you already suggested what we can do or what we should do, but how we can do it now? Can you give any idea? Do you have any suggestion like how we can do this in C programming language for garbage collection? Like our target is this, right? So how we can do that? So Adrian says find the count equal to 0, and then yes, we'll look for like which is not referencing anymore. The reference count is 0 for sure. And then then what we can do. Anyway, so the way we are using here, we are using, yes, so Matthew said, then move the next used space to the beginning of the unused space. Yes, for sure. Yeah, we are kind of doing the same thing. So the idea we are using here is called double buffering. Like we are using two buffer. Okay, and now I will show you like how we can use this double buffering to do it. Okay, so you will see like this class how we can do it, and in assignment number 4 you need to implement it actually. So get the idea very clear. It will be better for you for your assignment number 4. So the idea is we are using two buffers, buffer 1 and buffer 2, instead of just a single buffer and a pointer. Okay, so we are going to start from the first buffer. Okay, we'll fill it up, we'll update the buffer. Okay, and then when we are running out of memory, we are calling it no mem, and then we are going to copy the content of buffer b1 into buffer b2 and then set our pointer to b2. Okay, so now whenever we are copying actually from the buffer 1 to buffer 2, we are not going to use those unallocated things. Not the unallocated, it's already allocated, but those resources we are not using anymore. We are not going to copy anymore to the new buffer. Okay, so that's the main idea. So then there may be chance of, so you are just copying that, and then maybe you are inserting more object, right? And then maybe you are out of buffer 2, and that buffer 2, it can be fragmented as well, right? Because you are doing operation there also, like you are adding object or adding reference there as well, right? So whenever you are done with buffer 2, that means you are kind of the memory space is occupied, all the memory space of buffer 2 is already occupied, right? That one also can be like fragmented. So then what you are doing again, just delete the previous content of buffer 1 and then again copy your content from buffer 2 to 1. So it's just like kind of shuffling we're doing here. Okay, then again whenever you are running out of memory of buffer 1, again you are copying buffer 1 into buffer 2. So in this way, if you have a fixed size memory and like you in your code you have like kind of add reference and drop reference for sure, and then what you can do, you can just shuffling between these two buffers to just, you know, not using those like resources anymore that is unused, right? So you can free up those spaces, right? In this way. Is this idea of double buffering clear to everyone? Is there any question so far? So I'm repeating again, we are kind of using two buffer. Whenever a buffer is full, we are copying the content, only whatever the content the program currently using, not the unused ones, to the second buffer, like sequentially. Okay, then we are using the updated buffer for execution of our program. Whenever the updated buffer is full again, so it can be fragmented again. We're going to again shuffle this, doing the same thing like copying from buffer 2 to buffer 1. Again, if buffer 1 is full, again that can be also fragmented. We'll do what we'll do again, copy, delete the previous things in buffer 2 and then copy from buffer 1 to buffer 2. So you will do, I didn't understand. Okay, so Matthew asked, when you switch buffers, how do you change the pointers you already gave out to the old buffer? when you switch buffer, how do you change the pointers you already gave out for the old buffer? We'll see one example. Okay, I didn't understand I didn't understand the last 2 points. Okay, so what is happening in the third bullet point? You are out of memory for buffer number 1, right? And then you are copy the contents only the use one from buffer 1 to buffer 2. Okay, so now buffer 2 is out of memory. You are doing like other operations in buffer 2. Okay, now buffer 2 is out of memory and buffer 2 is also fragmented. So then what we're doing, previously you had buffer 1, right? So buffer 1, you can delete those and then you just copy the content of buffer whatever that you have in B2 into B1 again and set your buffer to B1 again. You are just shuffling. Then again the same thing. You are out of memory for buffer number 1. Again copy the content of B because your current buffer is set to buffer 1. Okay, you will copy the content of B into B2, again shuffling, and then set your buffer B2. Is it clear? Okay. Min Long who asked that. So when B2 is full, you override B1, copy contents from B2 to B1. Yes, you override B1 by copy contents from B to B1. Yes, that's the idea. Whenever you are copying, you are just using the used portion, not the unused portion. Is it okay? Okay, so this is our current situation. Suppose how we are going to do the garbage collection then. Okay, suppose you already know we have like these properties, number of bytes, like the size, right? Start address, how many times. So no, this reference is actually like the ID. So this is the ID number and count is like reference count, how many times it is using. Okay, so now you can see that after this is ID1, this is ID3. So we are dropping this, we actually dropped by reference using this ID2. Okay, so that's why it is white now. Again you can see that this is ID number 3, this is ID number 5, there was something ID 4 that was dropped, right? So what we are going to do now, so this is the actual scenario, our target is this, right? Clear? So what we are going to do, so this is the thing we are going to do, like I described, using the double buffer, right? So if you think like this is your first buffer and this is your second buffer, right? So we are trying to copy from the first buffer to the second buffer, right? And then you know that your current buffer was previously pointed to the first one, right? But now you have to change it to the second one, right? So that's the thing you need to do for. So what actually we're doing here, there is no such thing called the garbage collection, right? We are just kind of bypassing it, right? We're using kind of a buffer which is a linked list. We are kind of using a memory size here, right? And then whenever we are dropping something, we are not using anything, then we are using a second instance of that one, like the buffer, same concept, right? We're just kind of copy from there what is being used, right? So by this way actually we can implement the idea of the garbage collection, right? So there is no such thing in C what that works like a garbage collection, but we are kind of coding something or designing some idea but which will act like the garbage collection, right? Is this idea clear, everyone? Any other questions so far? Okay, so now I will just give you one example like how these things actually working. Okay, and you have to understand it well to design your compact function for your SMR4. Once we copy from B1, so another question, once we copy from B1 to B2, then we do clear the B1, yes, for sure. Okay, yeah, you need to clear that one or free those spaces totally once you've done the copy. Any more question? Okay, so we have actually another two pointer. One is we are using memory block start, another is we are using memory block end. Okay, so at the very beginning they are pointed to null, right? Then suppose the first insert object is coming. We are done with this, right? Then we know that the memory block start and memory block end will be pointed to the same ID, that is the reference one, right? Clear? Then we are adding another object. Okay, so we need to update this memory block end pointer just like that. Clear? So this free index, what is that one? It's kind of like in which position where we are going to start. Why it is 200? Because the very first one is 100 byte, right? The second one is 100 byte. So whenever you are going to insert the next one, for sure it should be starting from 200 position, right? Here. So now we are adding another one. We are updating this memory block end pointer, right? And then we are updating the free index because the third one is also 100 bytes. Clear? So now after that we are adding another one. The size is 250. So we know that the free index will be 550 now. The memory block end also get updated, right? And at the last, this will be pointed to null, right? Okay. So now what we are going to do? At the very first thing, check if there is room to allocate. So here we have more room to allocate, right? So if it is not, then only we are going to call a function called compact. Okay, this function compact actually works like a garbage collector, nothing else. Whenever we are out of memory, then only we are going to call this function, which will act like a garbage collector. Clear? So we have to check if there is room in the memory, right? We can create object or allocate object, right? Okay, if it is not, then it will just return null, right? If it is failed, right? And then we are going to call our function called compact. Clear? Any questions so far? Tell me, that's what's the free index doing every time? Is it checking for available space or like making a space? Free index. So from the last slide, it's like when, like in which position you are going to insert the next one. Like the function name is insert object, right? So in which position you need to insert, you have to have that thing ready, right? Shouldn't be free index 301. Good question. uh, Maybe it's just like maybe it's just like maybe you can think like occupied index or something. Okay, maybe whenever you are inserting object, you can just increment free index plus one like that. Okay, I got your point. That is, it should be like, since we are using free index, it should be like 300 is not making sense. Yes, so for here it should be 201, for here 301. So maybe you can just think this free index as like the occupied index so far. Okay, and whenever you are putting the next one, you will just do like this one plus one. Okay. So Tahmi then alternative says yes. So there can be another reason for that one also. Yes. So we know that the index is always starting from 0, right? Okay, so is it makes sense then, Curtis McQuarrie? Yes, for sure. Yeah, thank you. Yeah, so yes, so if you think about the index things, it's start from 0. Yes. So any more question? Andrea, so this management system uses two parts, the buffer, which is implemented as an array, and the linked list is the second part. The buffer is actually working as a linked list here. Yes, it's an array, but the linked list, you know that for each of the portion of the array, you are using the linked list, right? Is it clear now? Like it's an array of linked list, kind of, because this is the buffer, right? So if you go at the very beginning, this is the buffer, right? So buffer contains the nodes, right? And each nodes contains those things, right? Is it clear, Andrea? Hopefully. Okay. So now we are going to see how we can implement this. Sorry. So we are here, right? Okay. So now we are adding another reference. So whenever we are adding reference, you know that the reference count will incremented by 1. So previously, this is the reference ID. Whenever you are calling the reference, add reference ID is 3, right? So it will just count will be updated to 2. Clear? And then we are dropping a reference now, and the reference ID is 2. So we are going to drop this guy. Okay, so we are making it count equal to 0. Clear? And then we are updating this, right? Clear? So we're kind of updating our link, and also you know that this portion got unused now because we just dropped that. Clear? So we have to make sure all the links, including memory block start and memory block end, are correct. So it's just like we need to update all the link whenever we are dropping a reference. Clear? So now this is our scenario. We talked about earlier about this one, right? So this is our scenario, how we are going to use the double buffering things to do this, from this to this. Clear? So this is our double buffering things. The function we're talking about, the compact, right? So what is going to do, so there is nothing as argument it's taking, right? It's not returning anything, it's just using one buffer to shift another buffer, kind of working like a garbage collector, right? Okay, so at the very first, like I said, the very first thing, the current buffer should be pointed to the buffer 1, right? Clear? Then we have some variable, we can use some variable like next reference, like the kind of next ID, right? Whenever if we have we are inserting another object, what will be the ID number or the reference number? For here it's 6, right? Then the free index is 550 for now, and we have total number of blocks is 3, right? Okay, we know that this is the memory block start and this is the memory block end, right? So these are the informations available so far, right? Okay, so what we are doing now, we are going to copy, right, from buffer 1 to buffer 2, right? So that's why this free index goes 0 now, right? Clear? And now we can use this memcpy, right? So it takes 3 arguments. First one is the destination, then the source, and then the number of bytes, right? So using this, we can do copy the very first ID, right? buffer 1 to buffer 2. Now our free index got updated to 100, right? Again we are doing the memory copy. We know that the destination is like the at 100 position, right? And the source is the previous, like the next node on that buffer, right? Okay, we can also use this memcpy to copy from the source to the destination, like from buffer 1 to buffer 2, right? Clear? So again, after that also we are kind of updating our node, right? Okay, so it's something like whenever we are using this buffer concept, the nodes are actually updated also regarding the buffer 2, right? So previously you can see that the start address of the second node was 200. Since we are using another buffer now, right? So it's now updated to 100 now, right? Because the second block we are just using here. Well, so Matthew asked what data structure is buffer 1 and buffer 2. This is the array of linked list. Each of the like the array element is the linked list. Okay, or you can think about structure also. Clear? Okay, so now we have similar way. We can just copy the second node from buffer 1 to buffer 2, right? Clear? And now we are just updating our free index as well. We are updating the start address for this third node, right? So it's 200 now. Okay, so previously your free index was 550, now it goes to 350. Makes sense, right? So now we are clearing this buffer 1. Okay, so what's the next execution? We'll just change our pointer to buffer 2, right? Is it clear? So this way actually what we are using the double buffering things to do the garbage collection, right? So now if you have like more things like the add reference or insert object, you have this unused portion, right? But there can be like again drop reference here, right? It can be again full. Then again what you can do, you can again shift these things to buffer 1 and empty this, right? Just like this, you are just shuffling between them. Is it clear? The idea is clear how we can use the double buffer things to work as a garbage collector. Any questions so far? Okay, so now I want you to think about this. Okay, what do we get with this strategy? What's the bad about this strategy? Any idea? You are using more memory when transferring data to the another buffer. Yes, for sure. The thing is that or maybe I will just wait for others to think about this or any other suggestion. What else is missing here, like why this is a bad strategy? Matthew said if you wanted a buffer size 512 kilobyte, you would need 1 megabyte of memory allocated for your buffers. Yes, there may be constraint on the size of the buffer. Yes. So Matthew said that suppose each of the buffer is 512 kilobyte, and then for you so whenever you want to do this, so this is actually the tricky things is that there can be some scenario that even you need to free up the memory because you are using another buffer, right? So you have to think that memory allocation also, right? Like you are kind of, you want to use those free things, but also you need another buffer too. So that's actually main constraint need to think. Okay, so it's something like, if you have it depends. So if you have very small memory, right, you shouldn't use these double buffering things as well, right? It depends. If you have very large, so if you, it depends upon your memory size, it depends upon your uh, designing of the code, it depends upon the problem, it depends upon how you are going to solve it, right? So there can be many things possible. So it's not like it's not a straightforward answer like when we are going to use this and when we are not going to use this double buffering things, right? So it depends upon the program. Why cannot we, so someone asked, why cannot we just shift the elements to the left within a single array? So that was already we discussed actually. So whenever you have this, right, so you have to do it like shifting the things will, I think it will be more operation. Okay, so you need to care about lots of things whenever you need to shift, right? So you have to deallocate these things, you are going to shift, you have to be careful like when these things end, you need to shift here, right? Again, what you are going to do, whenever you shift here, these things goes unused, right? Again, you need to delete this portion, right? So there are many things so it's rather than doing this thing like what we're doing here, it's just like you are doing many operations here, whatever you are doing. Method should you free buffer 1 after you have moved everything to buffer 2. Yes, we're doing that. Like here we're freeing the whole memory, right? We can just say free buffer 1. Okay, but for this one, you know that like the curtain said that why not we are just shifting things. We are not shifting things because it the like the operation will be like the number of operation will be greater than whatever we are doing now, and you need to take care of many things here like the position things, right? Is it clear? Okay, so we already discussed about this, like why it can be better as well. It depends. So if you have a very less memory, you shouldn't do it as well. It's better to maybe you know that other things. It depends upon the kind of problem, it depends upon the memory things. Okay, clear? So the buffer one is an array that holds the nodes like a linked list, who store where they start and how long they are. You can also think about an array, or you can think about a structure as well, um, that holds the nodes like a linked list. Yes, who store where they start and how long they are. How long they are, it's not like sounds okay to me. uh, for sure, like where the position they store, right? So we have these only four variables, right, for each of the linked list, right? So the how they, so whether they are using or not, it's actually depend upon you just have this link, right, like the next, right? Is it clear? So whenever you dropping those, right, so it's kind of unused resources, right? Is it clear? Is it clear for if I understand your question clearly. Okay. Okay, so now this is the end of the garbage collection. Now I will give you some idea about how we can implement the class thing in C programming language. So at first, what is class in C? So Adrian says structure, kind of, but there is no method, right? So whenever we say a class, right? So we say that some variables, the more members, we have this in structure, but in Java or Python, we have also behavior or the methods regarding a class, right? We don't have anything, right? Matthew said, wait, how do we change the pointers we gave out for buffer 1 when we move everything to buffer 2? Change the pointer like this, you were saying? Which one then? How do, like when the user calls add reference? So inside, whenever you are is it regarding the double buffering, like using this function compact, or in which case actually? Yes, add reference. Okay. So whenever we are using the add reference, it doesn't return anything. It's void. The return type is void. Is it clear? Whatever you are asking. Or maybe we can talk later after the class. Okay. So so what is a class actually, right? So Adrian says that it's kind of a structure, but in a structure we don't have the methods or the behavior, right? Then what is the inheritance? What is the inheritance? Anyone? Like, you know that you can inherit the properties from a parent class to a child class, right? That's the inheritance we already know in Java, right? Using in Java we use the extend keyword to just inherit any parent class, right? Okay, so it's kind of a blueprint to create the object, right, for class. So you know that in Java all the things are class, right? Whenever we make new instance, we use new. That means we are just creating object of a class, right? Clear? So it includes the data or information and the behavior, right? So data or information we actually use as variables, right? And behavior as functions, right? You can hear me now? Okay. So what is inheritance? The behavior that a subclass gets information from its parents, right? So what about the inheritance in C then, right? So there are no class in our C programming language, right? But how we can simulate this in C programming language? That's our main concern. Clear? So for this, we are going to use a new thing called union. Okay. So maybe I will start from this slide from the next class on Monday. Okay. So if you have any kind of question, you can ask me. I have the office hour today as well. Okay, so if you have any question, you can ask in the chat box. I'm here. So we'll finish these things, and then we have another topic left, and that is the kind of exception handling things in C, and then we'll wrap up our course. Okay, so those are the two main topics left for the next week class. So Rafi Kakar said validation method in essay number 3. Uh, validation method I already discussed in your EM Learn discussion. Okay. Uh, what I'm supposed to do in it? I already replied your question. So whenever you can post any question in discussion forum, I will suggest you everyone to check like whether the same kind of things already posted before or not. Okay. So you are going to validate, right? Validate the container. How? Suppose if your number of nodes is 1, right? So then it should be pointed to head, right? So those kind of validation, right? Is it clear? So depending upon the number of node, you are going to validate the members of those structure. So Matthew asked, okay, I'm still a bit confused about how garbage collection should work. Can you give me an examples how a user would use garbage collection? Okay, so the example, okay. So suppose you are going to create memory or add new object, right? So whenever you are say whenever you are going to do that, right? So if there is enough memory, right, so you can do it. Otherwise you are you should it should get null, right? Whenever you are having that null, you are going to use that compact method to do it, like the garbage collection things, right? Is it clear the idea how a user would use the garbage collection? Okay. So now another question, the implementation of the garbage collector confuses me. What is structure arrays need to get? The implementation we haven't gone into details, right? It's just like a bigger picture, whatever we covered in the slide, right? So you know that I already told like in assignment number 4, the same thing you need to do, like the garbage collection things. So it will be described there, okay? Like what kind of data structure you need to use, or maybe I will give you a skeleton, maybe, okay? So it will be written on the instruction of assignment number 4. Is it clear? Okay, so what reference will it give if we insert new object after we move to buffer 2? What reference will it give if we insert new object after? Reference means just a moment. So you know that we are done with this, right? So whenever you have like add or insert object after this, okay, so you know that it will be inserted at 350 of this buffer 2, right? Is this what you were saying? This is the reference, like the free index is the like kind of the start position where the new things will be inserted. So you, okay, I got your question now. So next reference, so this one you are saying, okay. Next reference is still 6 because it's not updated anything, right? So previous reference equal to 5, yes. So this variable, we are not updating anything, right? Or maybe we can design a system, right? So suppose here we just update our start address, right? We didn't update these things actually, right? We just keep the ID same. We can do it. We don't bother about the ID number, right? Whether it's sequential or not, right? How can is okay? We are not bothering about the ID number. It can be, like it can be random as well or like that. Okay, we just bother about the memory spaces, the unused memory spaces. Is it clear? Okay. Any other question? Okay, so if you want to contact me in my office hour, then you should get you can book the appointment. Okay. Now, Matthias, can you give an example in Notepad or something of how user allocates memory, uses the memory with add reference? I will do it on Monday. Okay. Is the object managed on umlearn the sample program? Yes, that's the header file, object manager.h. Uh, I have problem in make in assignment 3. Okay. What kind of problem? I have every file needed in folder. Okay. After make. Can you just finish your question? Maybe you are typing. I have message no rules to make target my string.h needed by main. So can you remember like how we did in the class? Maybe you can follow the slide for like the I think it's slide number 20. Okay. So what we do actually whenever you are okay with the interface implementation and the main file, then on the terminal you have to type make file, and this make file, like you can say vi then make file. Okay, so whenever using the make file, you have to be careful because you know that m is capital. Okay, then f is small, so you have to write just like this. You have to say vi then make file, and then you need to update the make file, right? So you know that my string.h it's coming because it's coming because maybe in your make file you haven't changed, right? Maybe you there is mystring.h, but in the folder there is no mystring.h, right? So you are talking about assignment 3, right? So in assignment 3 there should not be anything called mystring.h. Levi said it should be clang wall main c. Yes, yes, yes. That answer your question. But you guys should be careful. Whenever you are done, then you have to say vi, then space, then make file, and then whatever the command you are using, okay, you have to put those using. You know that this is how we do. So at first target, what's your target? Then the prerequisite, then the command. So suppose this is the one you need to do. Okay, so you are going to make this. These are the files needed, and this is the command needed. Okay, maybe you can just go to the this slide. There are some examples given as well. Like I uploaded that make file also. Okay, after that you just need to type make. Okay, it will use the make file. Clear? Any other question? Okay, then stay safe everyone. Okay, I'll see you guys on Monday then. Adrian says, I thought we just freeing it. Okay, so actually wanna ask, why is there a return in the destroy container? Okay, no, actually, the return is something, it's a boolean, right? So whether you can destroy the container or not, if you can successfully destroy it, then you are just return. Oh, sorry, no, I make it wrong. Destroy container. Okay, so you are just returning kind of a null value, nothing else. Yeah, you're freeing it. Yes, you are in destroy function. You are at first calling your clear function, like destroy all the things, then deallocate using free, and then you are kind of assigning null, because you know that you have to test. So whenever you are going to destroy, okay, if you get return back null, that means that it's a successful destroy or something like that. When a malloc is struct, it does make space for the pointers within it, but not what they point to, right? But not what they point to, right? So is it like you're saying the the malloc is working, but it's not pointing to the right address? Are you saying that, or okay, one by one? So maybe it's better if you just take the appointment in my you. It's the same thing. Like if you have to go to the learn, and then what you can do, go to communication, then Cisco WebEx, then appointment booking. You can book an appointment. So okay, so this way actually, it kind of mixing this question. Maybe I can go one by one. So at first, destroy container. Are you clear what I said? Okay, so then comes to the point that I think call chain is when malloc things, right? Okay, so are you, so if I'm understanding clear, you are saying that you are kind of using malloc for structure. It's creating the space for pointer, but it's not pointing to right. Like it's not working properly, you are saying? No. Then is there any way you can debug? Is the debugging issue then, right? So maybe there are some wrong thing, like without seeing your code I cannot say anything about that, right? Why your malloc things is not working properly. So maybe you can debug. I'm asking about malloc and how it works with structure. Is the same thing, like you are using size of structure, right, whenever you are using the malloc. So you know that we already talked about this, like suppose you have so it depends upon your members. So in the structure, okay, if you have like a integer and a char, right, so it is just allocate that much memory in total. So if suppose if you have 2 byte for integer, 2 byte for character, okay, then it will allocate the 4 byte of the first one. Like we already discussed. Like if you're using an array of structure, that is different, right? Like are you multiplying by 10 or something or something? I'm asking malloc and how it. Okay, that does answer my question. Okay, yes, yes. So it's not like not just create the space for one member, just create the like whatever the members in total, it create the space for that. Okay, So then comes to the next question. Can you write the explanation of why destroy container returns container pointer? The audio is choppy. Sure. Okay. So any other questions so far? Should every structure created is a pointer? Yes. That's how we design actually. Yes. Any other question? It's not created as a pointer. You are just you know that we are using the malloc here, right? Structure is not creating as a pointer. We are just like whenever we are creating the instance, we are using container type pointer. Okay. Like whenever you are creating a structure, there is nothing. It's a pointer, right? Pointer is whenever you are creating some memory allocation or kind of a instance you are declaring. Okay, it's more related to that. Whenever we are saying pointer type pointer, container type pointer. Does that answer your question? Okay, so okay. So any other questions so far? Otherwise, we can end today's meeting. Okay. So I know that you cannot do anything in the weekend anyway. I hope you will have all of you have wonderful weekend. Okay, see you then. Bye.